All right, diving in today, folks, to a piece of tech history that you guys requested. We're talking nickel cadmium batteries. We've got this report here covering everything from their invention, how to actually, keep them running, all the way to where they stand today. So our mission here is pretty simple: get you the good stuff, the interesting bits about NiCADs without, overwhelming you with all the technical details.
Yeah, so good.
So, where do we even begin with this NiCAD X story?
Well, it all starts back in 1899 with this Swedish inventor, Waldemar Junger.
Okay.
He puts together this battery using nickel oxide hydroxide and metallic cadmium.
Wow, 1899. That's pretty early.
It is. It is. He actually, he initially even tried using iron in there.
Really?
But yeah, patented it that same year. What's really interesting is how quickly it started showing advantages over the lead acid batteries that were kind of the big thing at the time.
I mean, that's pretty fascinating. I mean, what made this early chemistry, so promising right out of the gate?
Well, the report mentions a few key things.
Hmm.
So first off, they were just tougher.
Tougher.
They could handle more abuse, more wear and tear.
Yeah.
Could also store more energy for their size.
Higher density.
Yeah, exactly. Higher energy density. And then also had the potential to charge faster and to last for way more of those discharge cycles.
Oh, wow. That's a big one.
Yeah, and they perform better across a wider range of temperatures.
Ah, versatile.
Exactly,
Yeah.
exactly. Plus, on top of all that, they could deliver power really quickly.
So like high discharge rate.
You got it. High discharge rate. Of course, the initial cost of nickel and cadmium, that was a bit of a hurdle early on.
Yeah, I can imagine. I mean, those aren't exactly, the most abundant materials.
Back then, especially.
Right. Now I know Edison was messing around with batteries around the same time too, right?
Yeah, absolutely.
Right.
1902, he gets a patent for a battery that used either nickel or cobalt with cadmium. But his main focus was really on that nickel-iron chemistry, especially for electric vehicles.
Makes sense.
There was actually even a patent dispute between him and Jumner.
Oh, wow. A good old-fashioned patent battle.
Yeah, and Edison ended up winning that one.
Of course he did.
So going from this idea in a lab to actual practical use, what were those big milestones in NiCAD development?
Yeah, what were the big leaps?
Well, a few really stand out. So by 1906, Junger actually had a whole factory set up in Sweden making flooded NiCAD batteries.
Oh, wow. So they scaled up pretty quickly.
Yeah, they did. Then around 1910, you start seeing nickel-iron batteries being used in electric cars.
Interesting.
But then a big breakthrough happens in 1932, and they come up with a much better way to get the active materials into the battery's electrodes.
Okay.
And this really boosted how much energy they could store.
So it's like a manufacturing improvement.
Yeah, a huge efficiency boost. Then moving into the mid-20th century, you start seeing the rise of these sintered plate needs.
Sintered plate.
Yeah, it's kind of, think of it as a more efficient internal structure, leading to better overall performance.
Yeah.
And adding lithium hydroxide to the electrolyte liquid inside also helped extend their lifespan.
Interesting.
So the U.S. starts making these in 46. Sealed versions start popping up in 47, and then in the early 50s, you get the first recombinant neoxide, which is actually really important to how they're made today.
Huh, okay.
But the innovation doesn't stop there. Fast forward to the late 80s, and we've got these ultra-high capacity versions.
Wow.
Yeah, and then in the 2000s, there's this new jelly roll design that helped deliver those higher currents you need for things like power tools.
Okay. That's a lot of progress over a century? It's pretty impressive.
It's quite the evolution.
So, all right, let's say I've got one of these in my hand. What can I expect? What kind of performance are we talking?
So typically they're going to give you about 1.2 volts.
1.2 volts. Okay.
Yeah, and with a pretty steady voltage output as they discharge.
Okay. Reliable.
Exactly. And then they could store, on average, about 40 to 60 watt-hours of energy per kilogram of weight. Now, a key advantage was their ability to deliver a good chunk of that power really quickly.
Right. We talked about that high discharge rate.
Exactly. And efficiency-wise, you were looking at getting about 70 to 90% of that energy back out.
Not bad.
Not bad at all. Self-discharge also improved over time, getting down to like 1 to 2% per month.
It's pretty good.
And, these things were known for their long life, often around 2,000 discharge cycles,
Right.
some even more. And get this, they worked pretty well in the cold, too. Temperatures as low as negative 20 degrees Celsius, all the way up to 50, sometimes even hotter.
Wow, that's a pretty impressive range.
Yeah. Now, one thing that was a bit tricky with them was that consistent voltage output. It actually made it hard to tell exactly how much charge you had left.
Right, because it's not like a gradual decline like you might see with other
Right,
chemistries.
exactly.
Interesting. So with all these great qualities, where would you have actually seen these batteries being used back in the day?
Oh, man. They were pretty much everywhere where you needed portable power.
Okay.
Power tools, walkie-talkies, emergency medical equipment, even professional video cameras.
Hmm.
They were even used in space.
What? Really?
Yeah, in early rockets and satellites,
Wow.
and even as backup power systems in aircraft.
Wow, that's pretty high stakes.
It is. They were also in railway lighting, security systems, RC cars, early cell phones, toys, flashlights. Even some of those early electric cars used them.
Huh.
And their robustness, being able to take a beating, made them really popular in industries like oil and gas and marine applications.
Yeah, that makes sense. So I mean, it sounds like they were the dominant battery for quite a while.
Yeah. Yeah, for about 50 years, they were really the go-to.
So what happened? What caused things to shift?
Well, the big change really started in the 1990s with the introduction of nickel metal hydride batteries, or NiMH as they're usually called.
Okay.
Part of that was driven by concerns over cadmium's toxicity.
Right. Yeah, that's a valid concern.
It is. And then lithium-ion batteries came along. They offered even more capacity, and they eventually became, much more cost-effective as well.
Hmm.
And then in 2006, the EU actually introduced some regulations that limited NiMH use to just a handful of specific industrial applications.
Oh, wow.
So now you really only find them in those niche areas like industrial backup systems and in the aviation industry, where reliability and that long lifespan are absolutely critical.
Yeah, yeah. So, all right, reliability, lifespan, that all makes sense. But how do you actually keep these reliable workhorses running? Let's talk a little bit about charging best practices.
Okay, sure. So when we're talking about charging, the speed of the charge or discharge is often talked about in terms of C rate.
Okay.
For example, a 1C rate means you're charging or discharging the battery at a speed that would fully charge or discharge it in 1 hour.
Makes sense.
So for NiCADs, a slow charge, say at C10 for 14 to 16 hours, is a pretty simple and effective way to go, especially for new batteries. It also helps to kind of even out the individual cells within the battery.
Okay.
Now, fast charging is possible with NiCADs,
Oh, okay.
but you really need those smart chargers that can actually detect when the battery's full. They do that by looking for either a slight voltage drop or a rapid increase in temperature.
Interesting. So it's not as simple as just, plugging it in and letting it go.
No, not if you want to do it right and not damage the battery.
Yeah.
There's also something called trickle charging, which is done at a very low rate and can basically maintain a full charge.
Okay.
But again, you don't want to leave it on trickle charge for too long. And generally, it's recommended to use a constant current to charge them, especially when they're brand new.
Gotcha. So are there any other sort of golden rules for maximizing the lifespan of these batteries through proper charging?
Yeah, absolutely. So always use a charger that's specifically designed for NiCAD batteries.
Right.
Don't try to, use some random charger you've got lying around.
Makes sense.
And slow charging is generally going to be gentler on the battery.
Okay.
For new batteries, it's good practice to put them through a few full discharge cycles to kind of get them, broken in properly.
Like an engine.
Yeah, kind of like that. And you really, really want to avoid overcharging. That's where those smart chargers with the automatic cutoff come in handy. Yeah, they sound pretty essential.
They are. And another thing that helps prevent that memory effect we'll talk about later is doing a full discharge cycle every few months.
Okay.
So don't be afraid to fully drain and then fully recharge them every once in a while.
Gotcha.
And try not to drain them completely too often in your day-to-day use. And always keep them at moderate temperatures when charging.
Okay.
Oh, and keep those contacts clean. If you've got a pack of multiple knives, consider balancing them periodically.
Okay. I'm taking notes.
Good.
All right. So we've got charging figured out. What about when they're not in use? How should you store these things?
Well, when it comes to storage, your two biggest enemies are going to be temperature and humidity.
Okay.
So extreme heat,
Yeah.
that's going to speed up self-discharge and just degrade the battery faster.
Mhm.
And extreme cold, that can actually reduce their ability to deliver current. And if they're fully discharged, they can even
Oh,
freeze.
wow. I did not know that. Yeah. And high humidity, that can lead to condensation, which can cause corrosion.
Makes sense.
So the best place to store them is a cool, dry place.
Okay.
Ideally, between 10 and 30 degrees Celsius
Mm.
and around 50% humidity.
Okay.
And keep them out of direct sunlight. Make sure there's some airflow around them
Okay.
to prevent any accidental short circuits. Maybe put some tape over the terminals
Oh, yeah, good tip.
and don't stack them in a way that could, damage them. Now, there are different opinions out there about the best charge level to store them at.
Oh,
But Nentas are actually pretty resilient when it comes to being fully discharged.
okay.
But if you are going to store them for more than a year, it's a good idea to fully charge and discharge them at least once a year.
Just to keep things moving.
Exactly. Keep them healthy. Oh, and with new batteries, those are usually shipped partially discharged. So make sure to give them a full charge before you start using them for the first time.
Good to know. All right, so let's talk about this infamous memory effect. What is that, and how much of an issue is it, in reality?
All right, so the memory effect, this is when a NiCAD battery seems to lose capacity if you repeatedly discharge it to the same level without ever fully discharging it.
Hmm.
So like the battery remembers that shorter discharge cycle, and it gets kind of stuck there.
This is a lazy battery.
Kinda, yeah. And this happens because larger cadmium crystals can form inside the battery.
Hmm.
And those are just less efficient at storing energy.
Hmm.
It was first noticed in satellites, actually, because they had very predictable discharge patterns.
Oh, interesting.
But the good news is that modern NiCADs are less prone to this than older ones.
Okay, that's good.
And honestly, it's often overblown.
Really?
Yeah, and people sometimes confuse it with something called voltage depression, which is a temporary drop in voltage that's actually caused by overcharging.
Okay, so two different things.
Yeah, two separate issues. The best way to avoid that true memory effect is to just, regularly fully discharge your NiCAD batteries, like every 1 to 3 months, like we talked about before. And if you do think you're dealing with the memory effects, sometimes a few slow, deep discharge and charge cycles can help to sort of reset things.
Okay.
Chargers with a discharge function are really handy for this.
Mm-hmm.
Now, other problems you might run into, you've got that voltage depression we talked about.
Right.
You can also have cadmium crystal growth if the battery's not used or charged properly.
Mm.
They can have a higher self-discharge rate than some other battery types. Overheating can be an issue if they're charged or discharged too quickly.
Right.
And then in some cases, you might even have electrolyte leakage.
Okay, so those are all things to watch out for. But in terms of, overall lifespan, how long can you realistically expect a NiCAD battery to last? What are the big factors that affect that?
Well, like we've been saying, it really varies. It depends a lot on how they're used and treated.
Okay.
For power tools, you might get, say, 400 to 600 charge-discharge cycles, which could be a few years of use.
Hmm.
But in, like, industrial or standby applications, these things can last for over 20 years.
Wow.
Yeah. Consumer electronics, maybe a few years. I saw one report that suggested 300 to 800 cycles as a general range, and they said you could expect the capacity to drop to around 80% after about 500 cycles.
Okay, that's helpful. So really it's all about how many times you charge and discharge them.
Yeah, and how deeply you discharge them. Shallower discharges are generally better for the battery's lifespan.
Makes sense.
Temperature plays a role, too.
Mm-hmm.
Keeping them at moderate temperatures is ideal.
Right.
And how fast you charge and discharge them, avoiding those extremes.
Okay.
And, of course, whether you overcharge or over-discharge them, those are big no-nos.
Right.
And then, proper maintenance and storage, all that stuff plays a role, too.
Right. So what are the main things that actually cause them to, degrade and eventually die?
Okay, well, there's a few key mechanisms at play.
Okay.
One is something called dendrite formation.
Dendrite formation.
Yeah, that can happen when you overcharge the battery, and it can actually lead to short circuits inside.
Oh, okay.
Then you've got cadmium crystallization, which happens when the battery's not used or charged properly.
Hmm.
That can reduce performance. And then over time, the electrolyte itself can start to break down. You can also have loss of the active materials inside the battery, and the internal resistance of the battery can increase, making it less efficient.
Makes sense.
And then, of course, there's that memory effect, which, can be temporary, But it can definitely contribute to reduced capacity if you don't address it.
Right. Now, I think we have to talk about the environmental impact here. Cadmium is definitely something that people are concerned about.
Oh, absolutely. Cadmium is a toxic heavy metal, and it definitely poses some risks if it's not disposed of properly.
Right.
It can leach into the soil and water, and that's a big part of why those other battery types like NiMH became so popular. And there are regulations in place, like those EU restrictions we mentioned earlier, that really limit their use now.
Okay.
But that also means that recycling EU batteries is incredibly important.
Hmm.
Don't just throw these things in the trash.
Right.
They're actually easier to recycle than lead-acid batteries.
Hmm.
And we can recover those valuable metals like nickel and prevent that cadmium from, getting out into the environment where it can cause harm.
All right. So last but not least, let's compare NICADs to the other rechargeable battery options that are out there. What are the key differences?
Okay, so first let's compare them to lithium ion.
Okay.
NICADs, they're just more forgiving. You can mistreat them a little bit more. They can handle those deep discharges better. They're just tougher overall. Good for those rough conditions. And they can have a really long cycle life, especially compared to some of those earlier Li-ion designs.
Okay.
They do have a higher energy density than lead acid, but lower than lithium ion.
Okay.
They also tend to perform better in extreme temperatures than some Li-ion types.
Interesting.
And they can be fast charged and are generally more rugged, often without the need for those complex battery management systems that you need with Li-ion.
Gotcha.
Now, on the downside, they do have a lower overall energy storage capacity for their size and weight compared to Li-ion. They have that memory effect issue, of course,
Right.
and there's that toxic cadmium to consider. They also have a higher rate of self-discharge and a lower nominal voltage than Li-ion.
Okay.
But, Li-ion is really the dominant technology these days, especially for portable electronics and electric vehicles.
Yeah, makes sense. All right. What about nickel metal hydride? How do they compare to that?
So compared to NiMH, needs are, again, more robust. They can handle those low temperatures better, and they can handle that ultra-fast charging.
Okay.
NiMH, though, has a higher energy capacity.
Right.
It's more environmentally friendly because it doesn't have that cadmium.
Right.
And while NiZed has that memory effect to worry about, NiMH can actually be a bit trickier to charge correctly. You need more complex charging algorithms.
Interesting.
But yeah, NiMH really became that more accepted higher capacity alternative to NiMH.
Okay. And then how about lead acid? We haven't really talked about those too much.
Yeah, so against lead acid, NiMHs are just, more robust.
Okay.
They've got better energy density, longer cycle life. So all around, a better performer for a lot of those applications.
So it sounds like even though neomates aren't as popular as they once were, there are still those specific situations where they really shine.
Yeah, absolutely.
It's fascinating how, battery technology has evolved over time, but there's still a place for these older technologies in certain niches.
Yeah, exactly. They each have their own strengths and weaknesses.
So I guess the big takeaway here is that white batteries, they were a really dependable technology that played a huge role in the history of portable power.
Yeah.
Even though they've been surpassed in a lot of ways by newer technologies, those specific characteristics, that robustness, the long lifespan, that ability to handle those extreme conditions, it makes them the ideal choice for some really demanding jobs.
Absolutely.
And it's interesting to think about how that consistent voltage output, while it made charge indication a bit of a guessing game, it also made them very reliable for those applications where you needed that steady power delivery.
Yeah, for sure.
And that whole memory effect thing, while it is a real phenomenon, it's something that can be managed with proper care and maintenance.
Exactly.
And of course those environmental considerations around cadmium, that's a crucial reminder that we always have to be thinking about the responsible use and disposal of technology.
Couldn't agree more.
It really makes you wonder, what specific needs are they still meeting out there that these newer batteries just can't quite fulfill?
Yeah, it's a good question. It'd be interesting to dig a little deeper into that.
Right. All right. Well, that's a great deep dive into the world of NiCAD batteries. Thanks for all the insights.
My pleasure. Thanks for having me.
And to all our listeners, thanks for tuning in. We'll catch you next time on The Deep Dive.